All right, problem 8. Prove the identity. Pick the more complicated side to start off with. I'm going to say that adding or subtracting two trig functions is always more complicated than multiplying them. Okay, think about adding, subtracting fractions. It's harder to do that than multiply. So we're going to start on the left side again. I should probably mix that up. So I've got a 1 over cosine x minus, instead of just cosine x, well, we'll just say cosine x for now. And I'm going to think of these in terms of a fraction, so I'm going to rewrite that as cosine x over 1. Okay, right off the bat, what I see then is I have fractions I need to put together, so I'm going to multiply top and bottom by cosine x. And what's that going to give me? That will give me a 1 minus cosine squared x over cosine x, the common denominator. All right, from there, we have something squared plus or minus 1, so think Pythagorean identities. I'm going to do some scratch work over here. I know that sine squared x plus cosine squared x is equal to 1. And to get this 1 minus cosine squared, basically we're just going to minus cosine squared x from both sides. Whoa. Come on. And that's going to leave me with a sine squared x on the left is equal to 1 minus cosine squared x on the right. So in other words, I can replace this 1 minus cosine squared with just the sine squared. So we have a sine squared x over cosine x. Okay, and where can I go from here? Well, at this point, it's helpful to look at what I'm shooting for. I want to end up with sine x times tangent x. Now, I already have the sine, and I know that sine over cosine is tangent. So what I'm going to do is I'm going to split this apart. I'm going to rewrite it as sine x times sine x over cosine x. And then from there, we'll say I'm done. I've got my sine x that I'm shooting for. And then the other sine over cosine, that's my tangent. So that's how we get to that sine x tangent x.